So this is the last part of 2-3's warm up. It says use the polynomial, find the possible roots and the actual roots, okay? This, and I said it, but I'll say it again, this one is factorable. The one in your quiz is not factorable. So we're going to pretend that it's not. We're going to work through the motions as though it was not factorable, okay? So to find the possible roots, I'm going to look at my polynomial. I'm going to make sure it's in order, decreasing degree, and it is. I'm going to look for the factors of the last number. So it's 12, which means 1 and 12, 2 and 6, 3 and 4. And then I'm going to look at the factors of the first number, which would just be 1 and 1. Then I put plus and minus all the factors of the last one, 1, 2, 3, 4, 6, and 12, over 1, which means my possible roots are negative 1, positive 1, negative 2, positive 2, negative 3, positive 3, negative 4, positive 4, negative 6, positive 6, negative 12, positive 12. Then it wants you to find the actual roots. So this is where I start to test them out. Now it doesn't say to use Descartes' rule here, but this is if you have the time to do a quick check, it could be beneficial. If you look at your initial equation, how many times does the sign change? Which tells you what? There is one positive root. Right there, I would stop and say start checking your positives. If there was 2 or 0 positive roots, I would plug in the negative x, so it would be negative x to the third plus 3 negative x squared minus 4 negative x minus 12. And I'd get negative x to the third plus 3x squared plus 4x minus 2. How many sign changes are there now? 2. So there is 2 or 0 negative roots. There is going to be a question that just asks you to find Descartes' rule to determine the number of roots, and then you're done. But then this one doesn't say it, but it could be helpful for you to figure that out because, like I said, because I know there's one positive root, will try all the positives before I switch to a negative. If it was reversed and it was 2 or 0 for a positive and 1 for a negative, now I'm going to try all the negative roots before I switch to the positive, okay? So it's designed as a time saver. If you have no idea how to do it, 10 points gone from the Descartes rule question, but also just don't do it here and you have to plug in more roots. It just takes more time, okay? So I'm going to start with the positives. I'm going to start with the positive 1 on the outside and then 1, 3, negative 4, negative 12. Bring down the 1. And it doesn't work, right? So then I go to 2. And that one works. So 2 is one of my roots. I'm going to take what's left here, x squared plus 5x plus 6. I'm going to factor it. The 6 is positive, so they have to have the same sign, right? So what's my factors of 6 that sum to 5? Positive 2, positive 3, right? Multiply together to give me a positive 6, add up to a positive 5. No, because then it's a negative 6. Yeah. So I get negative 2 and negative 3. There match my 2 negative roots, right? So I've got 1 positive and 2 negative, which matches one of the things that could have happened as far as Descartes' rule told me. That's the actual roots. If it says to factor it or put it in factor form or to put it in complete factorization, what does that mean? Put it behind the x, oh, not z, do z. X minus 2, x plus 3, and x plus 2 and x plus 3, okay? Yep.
Could you have factored in x squared plus 2x and then 3x plus 6?
And then factor by grouping?
Yeah.
Yeah. Yeah, you just got to keep going. Yeah. Becky. If you get a 0 as your remainder. Yeah. Yes. Yeah, that's what we did. That's what I would strongly recommend you do. Yeah. So this is the question, like I said yesterday, we kind of did, it was the last one on the example from the notes before. You're going to get something very similar to this on your test. Pay attention to the directions. If it says find the factors, if it says put it in complete factorization, if it says linear factors, all of that is the parentheses behind the x. If it says find the zeros, the roots, the solutions, that's when you list them out. Olivia.
What's going to be on the quiz is going to be what we learned today in 2.3?
Correct.
So So
2, 4. Go ahead.
no.
You sure?
Yeah, one of the answers on.
All right, so 2, 4 is complex numbers. If you remember this from Algebra 1, Algebra 2, sorry, this is your i's. This is your imaginary numbers, okay? So the imaginary unit I is the same as saying the square root of -1. It is imaginary because it does not exist, okay? You cannot find a number that when I multiply it by itself, it started negative and it gives me a negative. It doesn't happen, right? So we say the square root of -1 is I, which means I squared is -1. So we treat it almost like a variable when we're combining like terms, when we're multiplying, all that stuff, except when you see a I squared, you replace it with a -1, and answers can't have negatives underneath their roots. You always pull out the I. So if I had something that said square root of -5, the very first thing I'm going to do is take out that negative by putting an I outside the root. It could be in the front or it could be after the root, but it can't be under the root. So we are going to add, subtract, multiply, divide, do complex quadratic formulas with these, and then eventually put it together with what we did at the end of 2, 3. Right? There are 2 parts to your complex number. The real part, which is the number that doesn't have an I, and that we call A. The part that does have the I is the imaginary part, and we call that B. So the B is the number in front of the I. If it tells you to put it in standard form, it means to put the I last. Or the term with the I comes last. So if I had 2 plus 3i, that's standard form. The A is 2, the 3 is the B, okay? Again, the B is the number in front of the I. It does not include the I. If there's no A, it's called a pure imaginary number because there's no real part. So something like 2i would be purely imaginary because there's no real part to that. All right, so this is just examples of that A plus BI. If you look at the first one, this says -4 plus 6. So the real part is -4. A would be -4. And the imaginary part is B. 6 is B. So again, just the number, not the I included, is the B. Go to the second one. There is no real part, so my A would be 0, and my B would be 2. Oh, yeah, not yet. We're going to. It's just so you can identify the parts. And then if I just had 3 by itself, 3 is the real part. There is no I, which means B would be 0. The equity of complex numbers just said A plus BI equals C plus DI if and only if A equals C and B equals D. It's like having 2 variables. These 2 would have to be the same. And these 2 would have to be the same in order for my equation to be balanced. That's all. Yep. Of what? Oh, no, not even close. Not even close. Chapter 4. All right, so it says express as a multiple of I. This means you can't have any negatives underneath the root. It means if you have I squared, you have to replace it, that kind of thing. So what is the square root of -16? I square root 16, which then becomes? 4i. Good. So you put the I all the way at the end. No, because we're not solving it. If it said x squared equals 36, that's when we square root both sides. That's when the plus and minus comes in. Yep, we'll get there. Yep. All right, 7i squared becomes what? Why are we square rooting? Squared. You said the right number, but 7 squared and then I squared, and 7 squared is what? 49, and I squared is negative 1, so this is negative 49. It's the same thing as saying 7i times 7i. It's the same thing.
Oh, because
I squared becomes negative 1, not I by itself.
So why is that answer? If you were to say 7i squared, like together,
You'll
it's the
lose.
same thing.
Yeah, but that's not simplified as far as you can go, so you'll lose credit. Just make sure you get rid of any I squareds. All right, when you're adding and subtracting complex numbers, you literally combine your like terms just like you do with an x, okay? If it has an I, you can add it to another I. When you multiply it and you end up with I squared, that's going to get replaced with a negative 1. So you can't leave anything I to the second power or higher than I to the second power in an answer. They look like this. It's just going to say perform the indicated operation, right? So this first one, let's call it A, is subtraction. What do I do? Good. Negative is going to go to both of the things after this. So this becomes 7 plus 4i minus 9 plus 5i. And then combine your like terms. So the numbers without the i's, the real part comes first. 7 minus 9 would be negative 2. And then positive 4i and positive 5i, positive 9i. You can't.
We only simplify if it's an I squared.
Correct. Or higher. So it could be like I to the third and you can simplify that. But I'll get to that. I'll get to that. All right, B is just addition. Just remove your parentheses, combine your like terms. So 8 plus 17 is 25. Positive 3i, negative 7i, negative 4i. Easy stuff, right? Multiplication. If it's a binomial, we're just going to FOIL it out. But we don't leave it with an I squared. So if we FOIL it out and we end up with an I squared, we replace it with a negative 1 and then simplify from there. So they'll look like this. So A, I would distribute, right? First, 3 times 6 is 18. Outer, 3 times negative 2i is negative 6i. Inner, negative 5 times 6 is negative 5i, sorry. Times 6 is negative 30i. And then negative 5i times negative 2i is a positive 10i squared. You with me so far? Then you can combine these. This would be 18 minus 36i. And this I squared becomes a negative 1, so that becomes a minus 10. And then I get 8 minus 36i. B, do I distribute this exponent and say that that is 4 minus 3i squared? No, for the love of God, please don't do that, okay? You can't distribute an exponent on a sum or difference. We have to expand and FOIL this. So this becomes 2 minus 3i times 2 minus 3i. 2 times 2 is 4. 2 times negative 3i is negative 6i. Negative 3i times 2 is negative 6i again. Negative 3i times negative 3i is a positive 9i squared. With me so far?
Yes.
The I squared becomes negative 1, so this becomes minus 9. 4 minus 9 is negative 5. Negative 6i is negative 12i.
Are we finished last?
Yep.
Where's the 9?
The 9 got multiplied by the I squared, so the 9 gets multiplied by a negative 1 and becomes negative 9. Still good. Here's what happens on the quiz that you don't want to happen. People will either take this and add them, like there's a plus in between, or something that there is a plus in between, and multiply them. Don't do that. Okay? Be really, really careful. That stinks to lose credit on something like that. All right, the conjugate of a complex number is the exact same expression with the opposite sign between. So the conjugate of a plus bi is a minus bi. The conjugate of a minus bi is a plus bi. Same numbers, opposite sign in between. When you multiply a complex number by its conjugate, you get a real number. The i's will cancel out. The I squared would become a -1, and the i's themselves will cancel out. Just like when you're multiplying x minus 3 and x plus 3, what happens to that multiplication? If I did x minus 3 and x plus 3, it becomes the difference of two squares, right? It becomes x squared minus 9. We lose the middle term, right? Same thing's going to happen here with your complex numbers, except notice that the sign in between becomes a plus. So the shortcut on a normal product without an a or without an I is the a squared minus the b squared. The shortcut with an I is a squared plus b squared. So if I just did x minus 5 and x plus 5, the shortcut there is x squared minus 25. The first one squared minus the second one squared. But if there's an I, if it said x plus 3i and x minus 3i, it's the first one squared plus the b, which does not include the I, squared. Because I would typically multiply that out, the last term is going to be negative 9i squared. The I squared changes to -1, which makes that positive 9. So if the shortcut throws you, don't use it. It is when you get to, yeah, because I could FOIL that out. Like if it wasn't, I would have to do, let's say it's this. Right? X squared plus, minus.
You could do this one.
Plus 5ix minus 25i squared. These cancel. This becomes -1, which makes that positive 25. And I get the same thing I would get from the shortcut. You're going to use this if you, so I would advise the shortcut, but if the shortcut throws you off, just FOIL it out. You'll get the same answer, okay? It's a squared plus b squared.
It's just confusing because with regular.
If the I is not there, it's a minus, and if the I is there, it's a plus. Yep. All right, so this one just says, write the complex conjugate of the complex number, then multiply the number by its conjugate. So what's the conjugate of 7 minus 10i? 7 plus 10i. So I have two choices when I go to multiply. FOIL this all out, or use my shortcut, which is 7 squared plus 10 squared. 49 plus 100, 149. The A, the B. Shortcut is a squared plus b squared. Correct. The plus makes the I go away.
So then if there's no I, it's positive?
If there's no I, it's a squared minus b squared. Yeah.
So you always add these.
Yes.
No matter the sign,
Say again.
no matter the sign, you always add.
Yeah, because you're going to square it. The I squared would make it, right? Normally, if it's a positive and a negative at the end, my product would be negative. But then both of them would have an I, so it'd be a negative times a -1. It's always going to change it positive.
So it's just the sign that you change.
Correct. Yep. So what's negative, the square root of -5? 5. So close. I square root 5. It's still underneath the square root. What would be the conjugate to that?
I minus
Don't separate the I and the 5.
negative I square root 5.
Yes. Negative I square root 5. Think about that, right? That's really 0 plus I root 5. So the conjugate would be 0 minus I root 5, right? So it's the opposite sign. Now multiply these together. So I times negative I is negative I squared. Square root 5 times square root 5 is what? 5. This would be squared, sorry. Negative 1 is just positive.
So conjugate was just the opposite sign.
On the I term. Yep.
That's getting
The A stays the same.
When you're finding the conjugate, though, isn't it the opposite?
No, the A always stays the same.
No, on A.
Yeah, the A stays the same.
No, I mean like,
The sign changes here.
yeah, on
Yeah.
question A, the sign changed.
Same here, the sign changed. So when you multiply a complex number by its conjugate, it gets rid of the I. That's the whole point of it. So there shouldn't be an I in the answer. And the reason we're doing this is when we start to put them in fractions. Oh, relax, folks. To eliminate a complex number in a denominator, we rationalize. The difference is we're not rationalizing with a square root anymore. We're rationalizing with the conjugate, okay? So if I had 5 over square root 2, I can't leave the square root in the denominator, right? I would rationalize by multiplying square root 2 and square root 2. So I'd get 5 root 2 over 2. That's with square roots. Now we're dealing with i's. What does it mean to have an I in the bottom? What does I mean? Specifically what? What does I mean? Square root of negative 1. So this is like the same thing as saying over the square root of negative 1, and you can't leave a root in the denominator. So you can't leave an I in the denominator, okay?
Wait, I thought
Right. So I by itself is the square root of negative 1. I squared is negative 1. You lose the root.
I thought it just wasn't
So we multiply the numerator and the denominator of the conjugate. So let's just say it's just I in the bottom. What's the conjugate of I? Negative I. So we would multiply both of these by negative I. I'd get negative 5I over I times I would be negative I squared, which is negative 1, which just becomes negative 5I.
Why do you multiply by negative if we don't do that on the top?
Because there's no I in this.
Yeah, but you multiply times a positive. Shouldn't you multiply by?
Because there's no I. In order to get rid of an I, we have to multiply by the opposite. Yeah. And not so much when it's a single term. You actually could have just multiplied by an I here, but then you'd have to divide by negative 1. But when you get to this, when you get to ones like this, you have to change the sign in between. All right, so look at A. There's an I in the bottom. The I can't stay in the bottom, so what do we multiply by? Negative 5I in the bottom and the top. So the top, what's 3 times negative 5I? Negative 15I. In the bottom, what's 5I times negative 5I? Which becomes?
Positive 20.
Negative 25 times negative 1, which becomes positive 25. Can I simplify that? What would it be?
Would be 3 over 5.
Good. Which you'll either see it like that, or standardized tests love to do like a 3/5 and put the I separate from it. I don't care which way you write that. They're both right. Okay, you can put the I on the top, or you could put the I out after the fraction.
Well, we have to keep the I.
There's still an I in the top. So this is how we wrote it the first time. And I said standardized tests like to write it like this to separate it out into a fraction and then the I by itself. No, those are each different answers. Yeah. No.
But either way, it's correct.
Yes. Negative 3/5 I. It's just not that bad. You guys are such. All right. What do I have to multiply by?
Positive
5 plus 9I. You're welcome. I'm giving you extra practice on the multiplying. Top. What are you going to do? Foil it out. 7 times 5, 35. 7 times 9i. Did we forget that word already? 6i times 5, 30i.
How did you do that?
Cause I know my times tables?
I do, but
Cause I didn't stop to talk? 54i squared.
So would you just turn that into negative?
Yep, so this becomes a -1 and a -54.
what is it called?
I'm not there yet. So 35 minus 54,
19.
-19, right? And then 63i plus 30i, 93i.
Isn't that negative 54? Yeah, it is.
Yep, so I did 35 minus 54, which is -19, and then I did 63 plus 30. Now the bottom, you could FOIL out, or a squared plus b squared, do the shortcut. The a is 5, the b is 9, put a plus between them.
So you do 5 squared.
No. So this is a big, long expression, principal square root of a negative, which basically just says if there's a negative under the root, take it out as an I. That's it. What's important, I don't know. What's important is that you don't multiply out square roots with a negative underneath before you take the I out. So the I has to come out at the very beginning. For example, if I had square root of -2 times the square root of -2, and you don't take the I out, what happens?
You get the wrong answer.
I get the square root of 4, which is 2, right?
Yeah.
If you take the I out, which is what you're supposed to do, what do I get?
You get 4i.
Almost.
It's 2i.
It'd be I squared times 2, which is -2. And that's correct. You have to take the I out before you perform operations on them, okay? So if there's a negative under the root, it's the very first thing you do. Just take the I out.
Let me take your i.
Not the physical I. Let's not get violent. So notice the directions here. Perform the indicated operation, same as before, but now it says write the result in standard form. So you're going to make sure the I is at the end, okay? All right, what do we do? Take out the I.
Minus
2 more weeks and you get new seats. Nicole, you'll be safe. Now what? Yeah? All right, switch your seats at the end of every quarter.
7i. No, but I love my seat.
All right, 54. What do I do with square root of 54?
Oh, you have to simplify.
How did you get there?
9 times 6, and then you can square root 9 to the 3.
Good. So you can either do 3 and 3, right? 2 3s come to the outside, and the 2 and the 3 stay underneath. So 3i square root 6 is the same thing as square root 54i. All right, use the factor tree, right? So 54 is 6 and 9. 6 gets broken down into 2 and 3, and 9 is 3 and 3. And for a repeated number, it goes to the outside. Non-repeated stays underneath. We're going to do it again with the 24. How does 24 break down?
6 and 4.
6 and 4. 6 would be 2 and 3, and 4 would be 2 and 2.
Oh, I thought you just put.
You can just bring the 4 out, but you can also have started with 2 and 12, and that you need to keep going. So I just make a habit of keep going.
2 square root 6.
So there's 2 2s, 1 goes to the outside with the 7 that's already there,
Negative 14i square root 6.
and then the 2 and the 3 are still underneath, so that's 6.
On our quiz, we have to show the work of most of
No. Now what? Are those like terms? Yeah, what can I do?
Negative 7i square root 6.
So you can only combine them because they both have an I and they both have a square root 6. Okay, if it didn't both have an I or they didn't both have the square root 6, I couldn't combine them.
So if it was like a square root 5,
Then it would stay separate.
why do the, when you're factoring out the 6 and you put 2 and 3, why do you do that?
Like, why do you do it in general? Because you have to simplify the square roots. If a square root can be simplified, it's got to be
Yeah, but you still have to do
underneath. Because, that's as far as you can go. So, like, if I was just, let's say I take that 24, right? let's say I did 2 and 12, I would have to do 2 and 6 and 2 and 3. For every pair of numbers, one of those numbers goes to the outside of a square root. So there are 2 2s. A 2 goes to the outside, but there's a 2 and the 3 that doesn't have a pair. Those stay underneath and they get multiplied out underneath. So this can also be written as negative 11 square root I. Square root 6I. Just be careful and make sure that I is not underneath the root. Order there doesn't matter. I tend to put it in between so we know that it doesn't go underneath, but it doesn't matter. Questions on those? Okay. Same set of instructions, perform the indicated operations, and then write the result in standard form. So what am I going to do first with A? Take out the I.
Oh, you can't not FOIL, but like put it as 4 plus and then take out the I. Like,
No. Well, you can, but then you just have to do it twice. Doesn't matter if you do it there. You just can't start to multiply without taking out that I. Yeah. So then I can do 4 plus I root 7 times 4 plus I root 7. It's not. Those are not. They have to be the same with a different sign in between, right? Those are not conjugates. That's the same. You can't do it with the same. Has to be a conjugate. So 4 times 4 is 16. 4 times I root 7 is a positive 4 I root 7. I root 7 times 4, again, positive 4 I root 7. And I times I is I squared. Square root 7 times square root 7 is 7. So these can get combined. This is going to change to a negative 7 because I squared is negative 1. And I get 9 plus 8I square root 7. Mm-hmm. So if it's in standard form, the one with the I should always come last. That's all. Yeah. If it said put it in standard form, yeah. No, not no credit. Partial credit, depending on how many questions, yeah. Okay, look at B. What am I going to do first? Take out the I. Sounds so violent now. I'm teaching this a long time, and nobody has ever made me feel like I'm like violating somebody's threatening somebody by teaching it. Okay, now what? What? The 48. So 2 and 24, 2 and 12, 2 and 6, 2 and 3. Then what? One pair of 2's goes to the outside. A second pair of 2's goes to the outside. There's only a 3 underneath.
Could we simplify the negative 8 and the 4?
No. You can only, good question. You can only simplify that 4 into the 8 if the 4 also goes into the term that has the square root. It has to go in all the terms. You can't just do part.
You could do 4 and 12.
So now I have negative 8 plus 4I square root 3 over 4. Now I can simplify because they are all divisible by the same thing. So 4 goes into itself once, into 4 once, and into 8 twice. And I get negative 2 plus I root 3.
Oh, you could simplify all of it?
If the same number goes into all of it, then you can reduce it. But I can't do this. No, you cannot do that.
Wait, didn't you get 2 square root of 12? Wait,
I brought out one pair of 2's, right? I brought out a second pair of 2's.
77.
77 can't even be reduced. That one's not hard. Talking about this for a while, and I kept warning you it was coming back. I start to get excited when you guys whine. Make my day better. This is how that should have gone. Wow, Miss Crisler, thank you for reviewing such an important skill that I know I'm going to use again on all my standardized tests and all the tests moving forward. Thank you so much for being such a good teacher and reviewing a skill. Instead of, oh, that's what you sounded like. All right. That is the quadratic formula. Negative b plus and minus the square root of b squared minus 4ac over 2a. There's a really catchy tune if you want to go to YouTube and Google "To Pop Goes the Weasel." I won't sing it for you. You're welcome. Nope, not my strong suit. Singing is not. I'm doing you a favor. Okay, but you feel free to listen to it.
It goes hard.
Huh?
It goes hard.
All right, I can sing it in my head when I write it out, though. Okay. It's Pop Goes the Weasel, quadratic formula. Wait till we're done, though, and then you can play it for everybody. Okay. So, in order for this to work, your equation just has to be quadratic. What does quadratic mean? X squared. The highest exponent can be squared, right? That means everything we factor, everything that we've done, even root property, every complete the square, all of that stuff can also be solved using quadratic formula. That's why the quadratic formula is beneficial, is because when you can do nothing else, you can do quadratic formula, okay? The a is what's in front of the x squared, so the a is 4. The b is what's in front of the x, so the b is 12. And the c is what's by itself, the c is 15. If they were negative, the sign gets carried with them. Then I plug it in. So negative b would be negative 12 plus and minus the square root of 12 squared minus 4 times 15 all over 2 times 4. Now what?
144
Good. Order of operations tells me do that exponent first. 12 squared is 144. Minus, this would be 16 times 15. Thank you. Wait. Right? 240. Over 8. Negative 12 plus and minus the square root of negative 96 over 8.
Do we have to simplify that?
What's the first thing you're going to do? Take out the I.
Oh my gosh. I didn't see.
Yep. But not the way you're thinking. That's different. That's different. So we do that in the next section, though. Okay, can I break down 96? What goes into it? Could we just start small? Like,
12 and 8.
can we do 3? Can we do 3 or 2? Because you know those don't break down any further. How about 3 and 32? Because the more you could go a prime number in, the less you have to keep breaking both sides down, right?
But it's so much easier.
I would have never guessed 3.
But 9 is divisible by 3 and so is 6. Okay, what goes into 32? Why do you do that? 2 and 16.
1 and 32.
Don't do that.
It is
2 and 8, 4, 2 and 4, and 2 and 2. Okay, now for every pair of a like number, that number goes to the outside of the square root. So what pairs do we see? A pair of 2s, another pair of 2s. What's left under? The 3 and the 2. So on that, I still start the same way. Negative 12 plus and minus 4i square root 6, because the 3 and the 2, over 8. Am I done?
No.
Oh.
Separate it up.
Why did I get the 2 and the 2? So 2 2s comes to the outside as 1 2, right? Because
3 and 2. Where you get the right.
there was a 3 and a 2 that didn't have a match. So they have to get multiplied together and stay underneath. The lonely, they're left out, they're underneath, they're isolated, they're by themselves, the poor, sad little ones that don't have a partner. Okay? All right, now what?
Can you separate it out?
Yep. I can do, so I heard 2 things. Simplify and separate it out. You could do either one. Okay? 4 goes into all 3 things, so I have to do at least that, right? This would be 1, this would be 2, and this would be 3. And I end up with negative 3 plus and minus I root 6 over 2.
Wait, why'd you divide by 4?
Because that's the biggest number that goes into all 3 of them.
We have to simplify like that.
You have to, or you could break it apart. Negative 12 over 8 plus and minus 4i root 6 over 8, because they both would get the 8, and simplify them separately. You could do it either way.
So is the answer negative 3 plus minus I?
So there's 2 bands.
Correct. If you were to write these out, like if you're trying to list these, there is a negative 3 minus I root 6 over 2. And there's a negative 3 plus I root 6 over 2. That's 2 answers. Because it's quadratic, there should be 2 answers.
This is the first time we finished the math.
I know. I know.
This is quiz. Are you gonna have to write it like standard? Or could we-
No, you could write it like this.
Do we leave at 9 or 10?
This first one, I found a dance for the
Oh, hey. Okay, wait. I do want to, I know we're done with the notes, but the question came up before. What happens when an I is raised to a big power? And I want to show you this. Okay? Because this is like, standardized tests love this stuff. Okay, so I'm going to start with the I-20 first. Okay? If it's an even number, you literally just take and divide it by 2. Rewrite it as a power of 2. So this would be I squared raised to what power? 10. Right? Because in exponents we multiply, right? So just divide it. What is I squared? Negative 1. So if there is an even number of negative 1s, what's my answer? It's just 1.
You always divide it by 2.
Yes. So if it was 22, it'd be I squared to the 11th, negative 1 to the 11th. What's a negative to an odd power? This would be negative 1. Okay?
So you just divide by 2.
Yes. If it's even. If it's odd to begin with, take out that one odd number. So I would make this I-20 times I. It's I-20 times I to the first, right? And then, now I-20 we know becomes I squared to the 10th times I. I squared was negative 1 times I squared to an even power, or negative 1 to an even power is a positive 1 times I, which is just I.
Imaginary numbers are just so fun.
I agree.